3D printing technology has expanded from being a tool for rapid prototyping to printing functional objects. We propose 3D printed speakers, an enabling technology allowing new ways to integrate sound feedback with tangible mobile and physical interfaces, interactive characters, and interfaces for ubiquitous computing. Sound feedback is one of the most important functions of any interface. For example, a small toy can be embedded with a small speaker for sound reproduction. However, size, shape, and sound direction is limited by the speaker shape. If the entire body can reproduce sound, the objects can produce a more impressive experience for the users. 3D printed interactive speakers can take the shape of anything from an abstract spiral to a rubber duck, opening new opportunities in product design. Our 3D printed speakers are based on electrostatic loudspeaker technology first explored in the early 1930s. A thin conductive diaphragm and an electrode plate are separated by insulating materials. As the electrode is charged, an electrostatic attraction force is developed between the electrode and the diaphragm. The diaphragm produces sound through vibration caused by changes in its electrical potential. These speakers are simpler than common electromagnetic speakers because they consist of just two electrodes. The audio driver for printed speakers amplifies an input audio signal from a nominal amplitude to a high voltage 1000 volt peak-to-peak signal. This system uses a low current, high voltage signal that can be dangerous if a user touches the high voltage electrode. For this reason, the high voltage layer is on the interior of the object, and the ground potential diaphragm covers it. This driver and a 3D printed speaker can produce sounds around 60 decibels. In this example, a toy bear speaks to a user and communicates its distance from the computer. We use a standard embedded microphone to compute and track the distance between object and microphone. It also identifies the object that the user is holding by using coded ultrasonic signals. 3D printed speakers can be designed with any electrode configuration depending on the application's requirements. In the case of an electrode array, each electrode would be acting as an independent 3D printed speaker, though all of them share a single diaphragm. 3D printed speaker technology provides an alternative manufacturing technique for integrating loudspeaker functionality into objects and devices. First, the user designs a 3D object with a diaphragm. The object is then 3D printed. The current implementation of 3D printed speakers requires manual assembly. However, the principles of the design and application of 3D printed speakers are general and scalable. We believe that 3D printed speakers is an enabling technology allowing new ways to integrate sound feedback with tangible, mobile, and physical interfaces, interactive characters, and interfaces for ubiquitous computing.